Start recording. We are recording. So now explain it to me
So
again from the start.
explaining. So there are two ways that you need to check your hand. So those are winning conditions of the hand, correct?
Yeah.
And that is a open hand, right? So what this tells you is how you should check the hand of the player when he has not made a kun, chi, or pom. That's basically what this means.
Wait, wait,
Now,
wait, wait. Pause there. You said in a way that meant to me that you have an if and else condition. If this is not true, then you check for these. Is that what you're saying?
it's more, there's some shared parts in both, but to, let me describe the open hand. How you win with an open hand.
I'm actually gonna type that
What
down.
what does being open mean? I don't think you
How
know
to
that.
win with an open hand.
Yeah.
Let's go
Let me describe how
definition
to win with
one.
an open hand. And
Uh,
what is an open
Open
hand,
hand.
right? So an open hand is when you have all your pieces in your hand. Literally that. Oh, sorry. Closed hand. Put closed first. That's easier. Sorry.
Closed
I
hand.
thought you were, yeah.
Okay.
That's your closed hand.
I
What does
don't
it,
need I don't
what
need
does that
that
mean?
anymore. Okay.
That means that you have all the pieces, the 14, in your hand like domino. You know that when you in poker you
Yes.
have all your
Yes.
pieces, all your
Yes.
cards. That's
Yes. Yes.
exactly what
Yes.
it is.
Yes.
Open hand means that you have some pieces in your hand and some pieces forming one of the three different kinds there.
Yeah,
So
but
kun,
where?
chi, or pom.
Where?
Pom, chi, or kun on the table. Those stay facing up on
On
the
the
table,
table.
Like Yu-Gi-Oh trap cards or spells, I guess. Right?
Uh-huh. No, but traps as well. To get Kan,
Well,
Chi,
the
or
traps
Pon.
stay facing down, right? I meant facing up.
Yeah, but you can have spells facing down.
Well, yes, but generally you would want the spell up, right?
And if
To
it's a continuous
effect.
trap, you can keep it open. Anyway, let's not go in there. Let's not
Okay,
go in there.
that's Yu-Gi-Oh nerd stuff.
Okay, so open hand when you have some pieces in your hand and some pieces on the table in order to
Forming a
form.
kun, chi, or pom.
These are all or.
Yes,
Oh, by
that's
the
an
way,
open hand.
meta U. Okay, I don't know if you know this, but this is
Oh
very
yeah, yeah.
useful. Okay.
I use this to uppercase my SQL
Yeah, but I
code.
want the opposite. So, uh, how do you do
There
the
is an
opposite?
opposite. It's
I
downcase. Meta X and downcase. Just type.
I have
Oh yeah, it's not mapped on yours.
no, I do have it. It's meta I that I
Oh
called.
wait,
Okay, so
yeah.
it's meta U and then meta I. Oh yeah, I actually mapped that. Anyway, so in order to form con, chi, or pon. Okay, question. Um, how can you win using from an open hand? These are the conditions down here.
Focus on the closed hand. Those are the conditions for the closed hand.
Okay, winning.
Not only that is a winning condition, by the way.
Oh,
You need
there.
to,
When closed, you actually have more.
because remember, you need points to win. That's the winning condition, right? You need to have points and that hand.
Wait, you need both?
Yes, of course.
Damn. Okay.
And what I meant by mold, what I was saying late before, is the molds that you get, the piece, can give you 1 point. So let me open the.
Man, what a weird
Where's that?
game. They
Yeah,
decided to have
it's
two criteria instead of having a combination of cards. It's
there's
point
many criteria
combined
actually.
with the hand. That's weird.
Give me a sec. Let me get
I
Mahjong.
have a question though. So what
Mhm.
do you get points by having this hand?
Points by having this hand depends. That depends how you got the hand. That's the problem. So here is this the website? I think it was, I saw it on Wikipedia. Let me see. Wikipedia. Yeah, there you go. So here, let me share my screen.
Man,
You see?
let me grab your screen for a moment. Watch. Let me extract your screen. Okay, I can see.
So this is, these points are called these Hun values, you see? But
Yeah.
you need to be in these are Yakus. Okay, so I'll read what a Yaku is. Yaku is a condition that determines the value of the player's hand. It is essential to know the Yaku for game strategy, since a player must have the minimum of one Yaku in their hand in order to legally win a hand. So you can have that condition in your hand and call like that you won, you see? But if you form that on your hand and you don't have a Yaku, that means that you can't beat legally. So what does that
Wait,
mean?
is the Yaku the calling of the Richie thing?
That is one way to get a Yaku. So Richi means ready, ready. It can only be applied on closed hands. And let's read. When a player's hand needs only one tile to win, so you are in Tenpai. That's the mode that you are in. While the hand is closed, that is, the player has not called any opponent's discards to make melds,
Which is
which is
Han, Chi,
the
and Pon.
exactly.
Okay.
The player can opt to declare Ricci. Notice he can opt; he's not forced to.
Okay, so let me
This
ask this
Yak.
question.
Mhm.
Can you have 7 pairs, not call Richie, and now what happens when you do that?
Uh, okay, there's another condition, which is at Sumbo. Let me show the 7 pairs. One case here. A hand is completely composed of pairs, as the hand contains neither a four meld and pair combination. The hand is one of the two exceptions for the rule requiring winning hands to have four groups as a pair. Blah 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 blah. Whatever. So you see here that it's all pairs.
Yeah,
This is
7.
this.
Yeah, this is
So
what we
let's suppose that you
implemented.
have this hand and you get this. You see?
Yeah.
Then you are with your closed hand and you gain two yakus. Two hands, sorry. So
Okay, but
that gives
okay,
you
okay,
that gives
pause.
you the
Pause
possibility to
there.
win.
Pause. What is the chu again?
It is the amount of points that you get. So you need to get these points in order to win.
Okay, but can you win without points and only having a hand?
Only one case, and that is a luck here. Yako based on luck. So at sumo, called self pick, it gives you one value, one hand value, closed hand only, and it is when a player has a closed hand and draws a winning tile. So you are in a condition to win like this, and you draw a tile from the wall or the dead wall. One hand is added regardless of the hand value. That's one
Man,
case.
I
You
have
see?
so many questions. Why do people complicate games? Anyway, let me ask my questions. Now, the 7 pairs. Let's say that I'm one piece away from having 7 pairs,
Mm-hmm.
and I don't declare Ricci or whatever it's called,
Yep.
and then I draw the missing piece. Am I gonna have two hands or one hand?
You have one hand and you can win. You have 2 points. You satisfied the condition already, which is having at least one. You have two.
What?
You
So
need you need at least one, right? Do you understand that? Throwing the stick, which is calling Richie, gives you 1 point.
yeah, but I didn't call the Ricci.
That's fine. You gain two if you have only pairs.
Yeah, but it is written down there that if I have based on luck, that if I have a winning condition, I win.
If you're drawing the piece directly, that's luck. That's a luck based point that you
Man, I'm
get.
so confused. I'm gonna describe it differently. I have 13 pieces on my
Yeah.
hand. I ju- and I
Yes.
just and then I'm about to draw another one,
Yes.
and let's say that the 13 pieces will form 7 pairs if I draw that piece, and then I
Yeah.
draw it. Then I draw it. Is that a winning based on luck, or is that the 7 pairs?
Did you throw the stick?
No,
Wait, you have 7 pairs in your hand, you said?
no. I have 13 pieces. I'm
Yeah.
about to draw something from the wall,
Yeah.
and I have 13 pieces that is like 6.5 pairs. Okay?
6.5 pairs. Okay.
Yeah, and then I draw the other half, exactly like the
Okay.
example above.
Yeah.
And I don't throw the stick before that.
Yeah. Okay.
Is that winning based on luck, or is
Seven
that seven
pairs.
pairs?
That's 7 pairs.
Okay, okay, so let me ask you this. It's saying in the description of the based on luck that when a player has a closed hand, which is written in that 7 pairs is closed hands only,
It
and
is
draws
overlapping with the 7 pairs. Yes.
a winning tile, which is what I just did from the
Yes.
wall, one hand is added, but you said two there.
Yes.
So what the
Because it
fuck?
was a 7 pairs. It's
Oh, okay.
overlapping. These
Okay, I
rules are
see.
overlapping.
Okay, so
You see?
but the one above matters more than the one below.
Well, I'm not saying it matters more. You can add the points if that's the case.
Wait, but then again, 2 points, one or three? That's my question.
Three. You got two here and one here.
Oh, okay. So you can combo in this way.
Actually, that depends on the rules. So, okay, that's a. I think the rules I played with a guy. I don't know if he made that up, but the rule was that you would like you see that the 7 pairs is already true.
Yeah.
So that was taken into consideration that it overlaps with this.
So you get 2 points only.
You get only two, yes.
Okay, okay,
But
I see.
I've seen other people make. I don't know how computers implement this. Actually, I should check. But
What the
there are other
N64 does?
interpretations that it's both. You see?
What the N64 does?
Good question. I need to see the punctuation it gives you. I don't know.
Wait, so you have the game, you play the game constantly, and you
I
never
didn't pay
reach.
attention to that, man. Well, come on, dude. There's man. Look at this. These are all winning conditions.
We
Do you
are
think I'm
so
gonna
fucked.
remember them?
We
Like
are
what the
so
heck, man?
fucked.
Look at this. It keeps going. Ancient or local Yaku. What the heck? I didn't even know that. Anyway, we don't need to implement all of these, by the way. I think if we do like four of them, that's already good enough.
Okay, but I have another question. Do you win
Yeah.
the game by reaching a certain amount of points, or do you win the game by reaching a particular hand?
There are. Wait. What do you mean?
Okay, let me
Uh.
ask you like this. So in my example, I had 6.5 pairs,
Yeah.
and I I draw another one, and I had 7 pairs, and again 200,
Yeah.
2 points. Fine.
Mm-hmm.
My question is, what is the winning condition of the entirety of the session? Let's call it session. I think it's
Okay. So
easier.
that's like 4 games.
Okay. Okay. So you have 4 sessions, which we are calling
Four
games. Let's call it four
sets.
games.
Yes.
We have 4 games that composes a session, and we accumulate points each game. Is that what you're saying?
Yes. At the end of each game, there will be a calculation of who lost what and who won what. So, for
Okay. You can
example,
lose things.
yes. So I'll give you one example. So it's like Yu-Gi-Oh. Everyone starts with like I don't know 4,000 points, whatever, and those are sticks that you throw to make the Richi. Okay. So those are actually the same sticks. So
Oh, so
let's
wait.
suppose
The reaches are castable. You lose them.
yes, they're castable. Yes. But
Fuck.
don't worry with that now. Don't worry with that now. That's
Okay.
something else. So imagine the following. I have I'll just show an example how you calculate and how the mode of the game might impact the calculation that we need to keep track of. So, for example, you are playing fine, and then you discard a piece, and on the act of discarding, the next guy on you, after you, calls a Kun. So they had like 3 dragons, you're discarding the fourth. they can pick that and they form a kun, right?
Okay.
So they open their hand and make a kun. Perfect. They stole a piece from you, right? So they will skip the turn from the other person in between. It will go to that other person. And let's suppose now that he wins with that draw, right? So he makes a kun, and on the act of making that kun, he beats the game.
What does that mean?
That means that you lost, you gave the piece to him that he needed to win.
Okay. Okay. I see.
So you lose more points than other people. I think, in fact, in that case, you are the only one who loses points,
Okay, so
and
each
the person who
winning.
beat. Yeah.
Okay, but that does that apply only on open hand winning conditions, or we also
No,
decrease
no.
points on closed hands?
Every case. So, for example, I have my closed hand. You are discarding a piece. You are in Ricci, let's say, and you discard. There's one person in Ricci, and another is discarding a piece. I can steal the piece of that person in my turn, and then if I beat the game with that piece helping me, that person loses money, but also the other person who casted a Ricci.
No,
Now,
no,
let's
no.
suppose that I draw
That's
it
no,
from
no,
the
no, no.
tile.
You were explaining the other losing conditions. I want to know a more specific question. In my example, that
Okay.
I am about to draw this my other half of pair. I'm about to draw that from the wall, and I make seven
Mhm.
pairs, and the game is done.
You will draw it from the wall. Okay.
Yes. Who is losing in there?
Everyone.
Oh, so if I lose, if I win from drawing from the wall,
Yes,
everybody
everyone
loses.
loses points. In accordance to the amount of points that you have, the Hun
You
there.
accumulate points in 4 games.
And your points get transported to the other games, yes.
Okay,
And
is
you can go
there
negative, by the way.
okay? Is there a ceiling, or are we gonna just gonna the winner is gonna be the one that
No, no,
have?
it doesn't even have a floor, so you can go negative in
No, no,
debt.
negative I understand, but if I reach like 10, it doesn't matter. Or are
Nope.
we always gonna go to 4 games?
Uh, in fact, I think if there's a drawing by the end of those four, then it repeats and then it's 4 games again.
Oh, okay, there is a rebounce sort of. Okay,
And then it
Jesus
can
fuck.
go
Who
infinitely. So you
invented
can.
this shit?
Oh man,
Damn.
dude, this game is like Chinese, but modified by lots of people. So like, I think
You think?
Mahjong, and each one of them has like drastically different rules. The only one I know a little bit is the Japanese one because I think it's more predictable. Then there's the Hong Kong that I have absolutely no idea because they add more pieces and etc. There's the
Okay, okay,
Taiwan
okay.
variation.
Let's try to define a goal for today though, because I already understand. I already understood from the scrolling that you did that we're probably gonna have to make a domain-specific language to describe winning conditions. I understand that, but I don't have the creativity right now to make one. Uh,
Man, just do the function to check the pairs.
we already did that.
Okay, did you check the triplets and the pair?
No, no, we don't.
Then
Haven't
do
yet.
that.
Okay, you need to think, Mageta, about how are we gonna about the domain-specific language, man. What are we gonna do about that?
How to do that in LFA will be a challenge,
I
yes.
think there are a couple of ways. We can either go crazy with macros or we can go the closure route. The closure route is about basically putting the domain specific language in a map. And then we make an interpreter that grabs the wall and grabs the hands and grabs a
And
particular
you
map, which
AST
is going to be the
essentially. You
configuration of
generate
a winning
an AST.
condition. Sorry?
You generate an AST, basically.
Yeah, the map will essentially work as an AST. And then the interpreter, because we're going to make an interpreter, the interpreter grabs the wall, grabs the hands, grabs the configuration, and try to mash everything together. That's how I think Clojure would do it. But we have the power, like we can use macros in here to do something even more insane. I don't know if we should do that, but we can.
Let
Anyway,
me think about it. Man, I
anyway,
think we should have done this. I'm not even. Okay, this might be a meme. Might sound like a meme, but I think we should have done this in Emacs. It would be much easier, everything.
Why? Elaborate on that.
The language is easier. I could be doing all these macros right now in Emacs Lisp. Although I think we can
But
do it in.
the macros in LFA are common Lisp macros.
Yes, but there are other problems with the language, right? I already know the entire. I know libraries for Emacs Lisp. I know the standard library. I don't need to keep looking at the documentation for every 5 seconds. So I think that would be faster.
Oh, that would be
But I
faster.
think the main thing is we could integrate with actually Emacs and display things already as we do. You see, I think that would help.
No, but to me, like, display is not Dan's concern. That's front end shit. I don't care. What I care is state management and
Oh,
winning
it
condition
certainly
checks.
helps when you are doing rules to visualize the pieces and everything.
Eh, to me, that's I don't, well, if that's works with you, that's okay. To me, I'm fine with having a repo calling a function, seeing the result. I'm very fine with that. Okay.
But that's what I said.
No, that seeing function results in a repo is not displaying the pieces.
I'm talking about executing the thing on the fly on inside of a list machine and getting my result
But
there.
that's what we do right now. After we learn how to reload the repo, like
Can we?
we're
We
never
never.
gonna get out of this. We're gonna live in here forever. And then we need to restart. We just do this.
That's a still
Well, you can
that's
put
still
key
inferior.
bindings. You can put key bindings of Control C on
I mean, okay,
this.
that's good. I didn't know we were restarting. That's good,
We
but
are.
I think that's still inferior to the uh because it does reset the variables, right? I assume.
Yes, yes. We don't have integration. We can go look into that if the Emacs has some sort of integration with LFA, so we can do the Control C and it doesn't
It
reset
does have
anything.
a mode, but it's very garbagey.
Anyway, okay, I have to concede on that case though because I don't know how to do that yet. So yeah, Emacs list would be more convenient because you wouldn't lose the bindings. Uh, but okay, anyway,
Anyway,
so
so
let's
do the thing to
we're
check
gonna
the
implement this, right?
yes.
Okay. So let's think about how
Let
I want
me
to make a
look at the
function
rules and see
that
how I can
identifies a
make them.
set. I want to implement a function that is capable of identifying sets.
Okay, while you do that, let me see how the heck we're going to implement the other thing.
Yeah, because if we have that many rules, we have to. I think it would be very convenient, like uh, to do something like if this was closure. This is gonna be like pseudo closure. We would like hand and then closed and then um, pairs 0 straights straights 3 three of a kind. Like you can literally describe in which hand condition that's in and which combination of pairs, straights, and three of a kinds. You know,
Mm-hmm.
because then you can literally, well, that's actually going to be a little bit complicated because there is an OR here, so you have to encode the OR somehow. So like, and again, you can go completely crazy because we're gonna make it essentially make an EST by hand, and you're gonna make an interpreter for it. So the problem is identifying the best way to organize ands and ors and sums of combinations and stuff like that. And then if you want to go the macro route, we can, well, that's
Do
going to be
that
really.
function. Do the function first. Let's see. Let's go by baby steps.
Yeah, no,
This is
we
gonna
definitely
be
should do
very
baby steps,
messy.
but I think it's important to have that vision because I don't want to implement all of that
I
Wikipedia
get it. I
page.
get it. Yes, I'm thinking of how to do that right now, man.
Okay, so let me ask you this.
Uh,
A set is either straight or three of a kind, always.
it's straight. What do you mean by straight? The
Uh,
sequence?
the sequence, yes. Marinho is using poker nomenclature in here.
It can be one, two, three, three,
Yes,
four, five, right? It
yes.
can be that
Two,
or
three,
the
four.
same piece. So ping, ping, ping.
Yeah,
One,
three of
one,
a
one.
kind.
Yeah.
But a set is always three, and it's always either straight or three of a kind, right?
Yes, always only those two. Yes.
Okay. Um, I actually don't remember anymore. Which port are we using this thing? 4040. So localhost 4040.
I think we're gonna have to do this constraint based, which will be interesting. So you pass like a user
Okay,
state
this worked.
which contains all the necessary information that you need to check, and then the hand, and then you make a decision which winning
Ooh,
condition fits best.
wait. Did I? I didn't listen what you said because something broke in here. Let me actually pull. I don't know if I pulled, man. No, I did actually. So drawing is broken, but I thought we already fixed that the last time. I really did. Yeah, we did. It's using mset_add in here. So let's actually rebar 3 LFA repo and let's, I don't know, cannot draw. That's fine. I want to see how the hands are looking like. Okay, because we changed to multi-sets precisely because of the set problem. Because it would be very fucked to fix to identify sets. I have another question for you. Does the suit does the kind of piece matters for sets?
Suit of the kind of piece matters.
Yeah,
Well, it does, but for what?
can I have a chew of a character and a chew of a circle and a chew of a bamboo? Do they form a
I
set?
cannot be of different kinds, no. To make the
Okay,
triplets,
they need to
it has.
be both for sequences and both for repetitions. They need to
Yes,
be for the
it's
same
only
kind
two 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 of character, or two 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 of circle, or two 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 of bamboo,
and
or
sequence.
1 2 3 character,
Two, three,
1 2 3
four.
bamboo, one
Okay.
two three circle. You see?
Okay, that's okay. That's actually perfect because that means that we can just iterate through this and count how many threes we have. That's one. So let's implement that now. We're gonna make a function that's gonna be called straights, and we're gonna have a hand in there. Um, and then we're gonna have a maps fold, and then we're gonna have an if here, essentially. If I don't remember the equals in LFA because I think we are always doing pattern matching for instead of equals.
Use
we
the
just
Erlang. Oh, there's a equal equal, but in doubt, just use the Erlang equal.
Yeah, but I also forgot that. That's kind of the problem of using too many languages, but let's just use equals equals for now. Oh, we are using equals equals for the 7. Okay, that's how you do it. So if this is equals to 3, if the count, we actually don't care about the tile. Uh, right, we don't care about the tile. Yeah, we don't care about that. Yeah, we don't care about that. We do care about the count, and if it's equal to 3, we're gonna return ACC incremented. Do we have an inc in LFA, or is that a closure thing?
I think
Inc.
so.
We don't have an inc. LFA. Okay, so increment.
Hmm.
I'm looking at the wrong documentation.
I'll
LFA.
go have dinner. Be right back.
Sure.
But I think I have an idea of how to do the progression of the states.
Increment. You gotta be kidding me.
Have fun.
Thanks, Mageta. This is a closure thing? Are you guys kidding? Sure. Uh, so we increment the ACC. And that actually should be it, I think. That actually should be it. So how were we testing this before? I actually have no idea how we were testing this before. Okay, but that's the easy one. Counting the sets. Uh, and then we can make a function that receives the hand and straights. And I want to check. I want to check. Why is that like that? Thanks. I want to check if we have the same amount of straights as count straights passing the hand. Okay. Uh, straights. Okay. Mhm. Mhm. And now we need to implement. That's the easy one. We need to implement the sequences, and that's the hard one. We need to implement the sequences. So how exactly are we going to do that? I also noticed that this is ordered. This is sorted. So the first bamboos, that's actually kind of interesting. It's already sorted for some reason. I don't know why, but it is. It is sorted. Well, aside from things that are not numbers, I guess. 1, 3, 4, 2, 4, 6, 9, 6, 8. But I wonder if that's how maps do their things, or if this is actually just a representation thing. Do you know, Vinicius?
What?
Do you know if
Right.
maps in Erlang, if the like if you fold over them, if you fold over the keys and values of a map, is that always going to be sorted? The keys?
I don't think so. I don't think there's any like sorting.
Because if you look at my screen, you see that they are always sorted, the keys. 1, 3,
Mm-hmm.
4, 2, 4, 6, 9, 6, 8. Like being everything
Mm.
equal, the numbers are always sorted in all the hands. We have 4 hands in here. They are all sorted.
And
Is
I think I remember reading like some time ago in an Elixir thing that is still like Erlang maps that like up to 32 values in the map it kind of sorts by keys, but I think after that it doesn't.
but you always gonna have
So
14 in your hand.
yeah, you can. I mean, you can either like rely on that or you can just like sort and like manually sort to be safe.
That's fair. That's
I
fair.
would manually sort since it's like a small list anyways.
Yeah, let's actually see. Um, let's actually see. So is it easy to sort? No. Can I get the keys? Yes, I can get the keys. Hmm, That's interesting. So we only care about the ones that are one. I think Marinho did the prelude, removing zero, so I don't need to care about zeros. That's cool. Wait, if you're removing zeros, does that mean that I can just extract the keys and who cares? Is that what you're telling me? Hmm. No, we can't. Wait, why would we have zeros in there? That doesn't make sense. So when I do an add, I check the count. Yeah, this is always going to be at minimum 1 because this will always return 0 at least. When I do a remove and it's smaller than true, what if I only have 1? So I only have 1 of something and I do a remove on it. So that 1 is smaller than true, so we just remove it altogether. It's not going to be there. Yeah, so Marinho made it in a way that I can literally just grab the keys. Oops. Sure, sure. So let's make that function. So it's going to be that fun. Count. Actually, I named this wrong. These are not straights at all. These are three of a kind. These are not things. These are straights. Straights. Count straights. And I'm gonna receive a hand. Okay. Um, what are we gonna do? We need to extract the map. So let's do that first. So it's gonna be maps, keys. We're gonna get the hand. So that will give us these things. That will give us these things. I would like to iterate upon that, but it's very hard. It's actually very hard. Can I make a hand? No, I can't because we made the game properly. So to get a hand, we actually grab from the wall, as you would do in real life. So I can't get a hand easily in here. Okay, no, it doesn't matter. So then, after grabbing the keys, I need to do. I'm gonna have a list according to the docs. So what do I need to do? I need to do a group by because I want to group the ones that are the same kind, right? So we do lists Erlang. So let's see which functions we have available. I need group. And there's no group in there. I don't know if that's the latest group. Group lists Erlang. There must be, right? Group by. Partition, reverse. There's no group by in Erlang. Are you kidding me? Are we gonna have to implement group by? That would be kind of sad. Erlang discussions. Wait, Elixir has group by. But Erlang does not. Enum group by. Enum group by Erlang. Oh, those are probably equivalent of an elixir. I see. Um, enumerate. No, but in here you have two lists. I only have one. Fold for each. Let's continue seeing this. So there are keys, there are map, merge, next, remove, size, take, to list. No, I only need the keys. With what? What happened in there? Okay, thanks. With what is this? Returns a new map with the keys Q1 from Cayenne and the associated values from map 1. Oh, okay, so this is a sequence of thingies. Man, I thought was I dreaming Erlang doesn't have group by? There is a gist of someone doing it with a fold and also doing it with list comprehensions. So what is this doing? This is grabbing a list, grabbing an element from that, putting that in a in a tuple, applying the function to it, and that's the container. This is the accumulator, and then the fold grabs it grabs the key and the value and appends stuff into it. 14 years ago. Uh, sure. I guess we're gonna put that in collections. We need a group by for lists. Define list group by. We're gonna receive a function and a list. Uh, let's call this the list. Oh, function is can I do? I can do fun as well. So what that's gonna be funct maybe funct. Sure. Then I need to use the list comprehensions that I already forgot the syntax. So let's grab it in here. This is how you do list comprehensions. Oops. So let's put that in there. And then we're gonna have the list in here. We're gonna have an element. And then in there, we need to do a fold now. Oh, this is the return of the fold actually. Okay. So we just put tuple. Uh, how do you do that? I forgot how you do that. Is that a func call or funct passing the element? Is that is that how you do that? I'm not sure. Func call.
Is it done, Lemus? Because we have way more to do.
No, it's not done at all actually, because I just
I
discovered
cannot.
that Erlang doesn't have group by.
Ugh! Uh,
Lists folder. So then we're gonna have a lambda. We need the accumulator, which is gonna be. He's using a dictionary. What the heck is that in Erlang? Dict Erlang.
yes, it doesn't. Oh, that's so silly. I mean, you can make one
Well, I'm
easy.
making one. Like I found an Erlang implementation of one-liner, and I'm implementing in LFA.
Oh, let me see.
Why do they need a dictionary if they have maps? Am I daydreaming? What is the
I
difference?
think it's easier to pass.
Am I crazy? Why do they have
It does need the
dictionaries?
dictionary because it's grouping by a key, right?
What do you mean?
So it's grouping. Well, the elements on the that it's grouping by the sets, it will be the key, I suppose.
No, wait. Here's what it's doing. You pass a lambda and you pass a list. You do list comprehensions on the list, so you are iterating through the list, having another
Yeah.
one, in which the elements are tuples. The first
Yes.
element is the application of the result of applying the element to the function, and the second member of the tuple is the element itself. Then we are folding using a
Yes, and
dictionary.
your function should return the tuple key and value, right?
You mean the group by?
Well, on the fold, right?
No, but that's the thing. The fold should return
On
a
the
list of
map.
lists, right? Why is it returning a dictionary?
Because a dictionary is the what you're calling list of lists, right? Man, it's the same thing of an F sharp. It's creating like tuples. So, like, for example, you have A, B, and C, like whatever, and then the key for the thing would be the element that you grouped the set by. So it's like the head of the elements that you are grouping this set for.
Yeah, but I don't care about the. That's what I'm trying to say. I don't care about the keys afterwards, right? The keys are the results of the lambda. Agree?
The keys are the results of the lambda. Oh,
Let, let,
mm,
let's let's grab a concrete example for me to make sense. So look at this hand, okay?
hmm
I will do a group by kind. So I'm gonna grab each tile, extract the kind, and that's gonna be the criteria for grouping. So this is
bamboo,
gonna become a
right?
list. This is gonna become a list. This another list, and this another list. Agree?
Can you send me that this map, by the way?
Which map?
This Erlang map.
This the full one?
The hand. The
Oh, the
hand. No,
hand.
no, just the hand. Yeah.
Sure.
Hello, Manin.
I'm here. Hello.
Actually, I forgot. I can't do what I just did. Hello, money. Here's the map to you, friend. We're implementing group by in LFA, money,
Group by. Why?
Because it doesn't have
because
it.
because it doesn't have it. Because we are
Okay.
implementing the others winning condition, right? So I already implemented the straights because it's very easy. Just grab the ones that are threes and sum them up, right?
That's for triples, right?
Yeah, three of a kind. Sorry, three of a kind. I'm now implementing the sequences. In order to do the sequences, I asked Vinicius if this representation is just bamboozled me because I noticed that they are sorted if the kind is the same.
They aren't, but that doesn't matter. What you can do is say, okay, for each tile, just check the one above and below. And if you have at least one of each, you can remove one of each. That's why we implemented the mset minus last time, actually.
Ah, so you already thought about that, huh?
Yeah.
So our idea is to iterate through this. Actually, if it's in here, you already have it. We can't have
Oh, I see.
zeros,
So you
right?
want to check the neighbors? Is that it?
Yeah, yeah. So
Yeah,
we start from here.
Makes sense.
No, but that's not true though, right?
If you
Or you,
sort, you can check both directions
you
already,
don't
right?
need to sort anything. You just need to iterate over the keys and say, okay, for
but
this key,
Oh, right.
but
It's a map. It's a
it's
map.
a
Yeah.
map. So I ask Vinicius, can I use the assumption that for bamboo is gonna be the same, is gonna be already sorted?
you shouldn't,
Uh,
because I think this is actually implemented the same way that closure maps are, which is not specifically not sorted. It's a hash map.
No, yeah, but all of the hands are sorted, and I noticed that.
is that a display artifact or
Yeah,
is that
that's what I asked
really how they
Vinicius.
are?
Vinicius then said that he remembered in his memory that apparently upon 32 key to
They're
value
gonna sort
pairs.
14 elements. I don't think that's really a problem.
No, then Vinicius said to guarantee because it's always 14, just sort them all the time. And I said
Yeah,
fine.
I think that's
So I
safe.
was I was thinking about doing the group by because I was okay. I'm gonna actually group the same kinds because I'm gonna have to keep track when I go from the 7 to here, right, Marinho?
From
That's
the
why I want to
7.
group them. Because let's say that you reach this. You can't use your trick, first because this is a 1, and second because this is a different kind.
No, you can. You say, okay, this key is tile bamboo 7, right? All you
Sure.
have to do is say, okay, do I have one tile bamboo 6 and one tile bamboo 8? If I do, that's a sequence.
Okay, so you would sort the map and then iterate over
No,
the
you no, you don't need to sort the map at all. Just iterate over the keys.
and then you keep doing lookups in this, in here.
Yeah,
Why do you do the minus then?
because this will be in a fold, and you say, okay, here's the hand, the starting hand with everything. Here's the keys of the hand, and that's what we are iterating over.
Yes.
And then at each step, you say, okay, for this particular tile, can I make a sequence? Do I have the tile before and after it? If I do, I make a multiset with those three keys, and I just do an mset minus on the hand, and that's the step function for the reduce for the fold left.
Do you need to remove stuff? I don't get it. We are only detecting.
Because you don't want to use the same tile for multiple sequences.
Is that true, Magetta?
You don't use the same. Um,
If I have a 1, 2,
Depends
3 and a 2, 3,
because
4, can the 2 be the same? That's the question.
because here's the thing: you have two possibilities, right? They may render you two possibilities of two different pieces that you can draw that make you win, right? So you can't just disconsider the piece that has already been used. You need to check and include that again to see if it matches. For example, I have, let's suppose that I have only sequences in my hand and one pair. Okay.
Hmm.
So, but let's suppose that I'm lacking the one pin and I have the pair of one and one. So, and I have a two, sorry. And I have a sequence like two, three, four. I can opt to discard the four and then I would need a one. You see? That's one option.
No, no, no. But you were talking about different thing. Marinho is talking about detecting the condition, right? Detecting that you have four
Yes,
sets.
I'm saying that because you can't discard, you need to check two different conditions in that case.
No, no. But you were talking about to check if the missing piece, what is the universe of missing pieces that you can draw to win. That's what you're
That
talking
is a
about, right?
consequence of being able to beat the game because there are two ways to beat the game.
Okay. Let me put it this other way because I think I agree with Marinho now. You see this hand here, Magetta?
Yes, I see.
We are trying to grab a particular arbitrary hand of 14 pieces and say, do you have four sets of either straights, three of a kind, and one pair? That's it. And the answer is to check for how many sets you have. We can count how many three of a kinds, which is
What
already
you
here.
want is a boolean. Yeah, true. That's it.
Yeah, no,
I don't
but
know how
then
many
we need
possibilities.
to
I just
remove
want
this, right? We need to remove the ones that we already used.
why. That's why I'm asking. If you only want the true or false, then yes.
Yes,
But you
that's
might
it.
end to us. But what I'm saying is, you might end checking these. Can you check? Okay, now it's a question. I need to think about if that's possible. But is there a way? It's this non-deterministic, right? Because think about this. If you check in a sequence, everything only on discarding the things that you have already looked, and you don't look again all the possibilities of this guy, then does that mean that when you reach the end, you can say no when in fact you could check because of some other condition that you should have checked that you didn't? Because for every piece, you should check two conditions, which is there three or two and potentially three? You see?
No, that's the part that I'm confused. There's no potential in here because we already have the 14 pieces. You're not about to draw something. We are just detecting, just you said, as a boolean.
Yes,
So
but wait, you want to check if this hand is already possible to win? Is that
yes,
it?
yes.
Okay, I thought you were checking like if it's about to win,
No,
like
no,
if
no.
it's
That's gonna be
possible.
a separate conversation.
Yeah,
That's a more difficult check, Mageta.
that's way harder. Yes. Um.
You're here just to say you have 14 pieces. Okay? Did you win? Well, actually, let me refine that question because I just remembered that it's fucked that the answer. Did you win with 7 pairs or 4 sets of straight or sequence, straight or three of a kind and a pair? That's the only thing we care.
Yeah, but here's my point. I don't think you can just check linearly. True,
Ah, Barinho, I think he's
because
right because
the
maybe
pieces are used overlapping, right? They may be overlapped.
yeah, because here's the thing, Marinho. When we're about to check the sequences, we need to exclude a pair, right? Because we're not gonna use that. Agree or not?
Well, in that case, the correct algorithm would be okay, what are all the pairs that I can make? And then for each pair, you remove the pair and you iterate over the remaining
Yeah,
keys.
yeah. That's what I was thinking. You need to check for every piece all the two conditions, right?
Not for every piece though. For every
Oh
pair.
man, this is a combinatorial problem. This is
Not for every piece though. For wait, it's for every pair or for every piece, Marinho?
No, it's for every pair because you're going to remove a pair no matter what, right? To make a winning hand.
Yeah.
So you check, okay, with this pair, can I win? Do I have enough triples and sequences
No,
everywhere
so
else to
so we
win?
need to filter first the pairs. Let's grab the pairs first.
Yeah, you need to make every possible pair that you can make for each hand, right?
No, but let's
For
let's
each,
but before doing that, let's actually type that down because I'm gonna actually forget that. So pairs, um, pairs. I need to grab the pairs, so I need to do a filter, and I'm gonna filter over the hand. Actually, not even the hand, the pure hand. I need to filter. No, in this case, it is the full,
you
and
need
I
to
need.
find every tile where the count is at least two, basically.
Yeah, but do I have maps filter?
There is a filter for maps, in fact.
Are you sure about that?
I remember seeing it. I don't know the name, but I remember seeing it.
it's the
Okay.
kind of problem that Prolog would destroy.
That's true. That's also true. Oh, there is a filter. Okay, and the predicate receives the key and value. Okay, that's perfect. So we're gonna have a lambda, which by the way, fun is a keyword. I don't know if you know this. Does that matter?
It it's probably doesn't because I think fun is how you say, okay, I have a named function that's in the value slot of the symbol. How do I extract that so I can call it, right?
Yeah. So I would, do we agree that's how you get out the pairs?
Uh, maps
Oh, I need
filter.
then to get the I need well, let's actually do the closure thing. So closure, I need to grab that and actually pass to map keys, right? So maps keys. This is grabbing all the pairs, right?
Yes, that should be grabbing all the pairs.
Okay.
Maps, keys. Uh,
Yeah, this will remove the numbers essentially.
no, this is just going to list the tiles that have at least two of them in the hand, right?
Yeah, it's gonna remove the numbers because I'm grabbing only the keys.
Yeah, it's gonna remove the numbers
The
to give you
choose, I guess.
just the tile. Well, there could be 3 or 4 actually. That's the thing. So then for each
Ooh, it should
no
be
no
each
then for
three.
but then
Go
for
for it.
each tile in this pair,
This should be
you
a mod, no?
no, it should be at least 2.
At least that's not true. If you have four,
You remove 2 to make a pair, and then you still have 2 to make triples and sequences.
but you have two pairs.
Doesn't matter.
Okay. So this should be at least two. So this
The correct name for the triplets, sequences, straight, or one of a kind is meld, by the way.
meld. We can combine them later. Anyway, is this what you're talking about, Marinho?
Yes, if the count is at least 2, that means you can make a pair of this particular tile. Which means you then need to check, okay, if I remove this pair, the remaining 12 tiles, can I make 4 melds with them?
Four melds. It's
Yes.
only three melds, no? Am I crazy?
No, you have 14
Because
tiles.
yeah,
You
but
remove the pair, that means you have 12 left over.
oh, it's four.
12 divided by 3 is
I'm
4.
stupid. I'm stupid. It's four. Okay. No, but focus on the straights. This is a meld, right? Actually, we should put this. That's the name. Actually, thank you, Mageta. We're gonna have a melds.lfa. Cool. This is where these functions should live in. Actually, I'm gonna move that right now.
I
He's
think
harder than I thought it would be.
I
Yeah,
think
you
Magetta
grabbed
is
a cursed game, man.
actually right. We should use Prolog for this because here's the thing. Suppose you have a tile after you remove a pair that there are 3 of them, right? You have, let's say, 3 uh, east winds, for instance, right?
Yeah.
Actually, that's not a good example. Let's say you have 3 sevens of bamboos or whatever, right?
Okay.
Here's the problem. You can remove those 3 as a triplet, right? A meld of 3 of a kind.
Yeah.
But theoretically, you could also use those 3 to make 3 different sequences, right?
Yes, you could.
Yes, but that's the
So
problem
that's
that he
why I
was
said
explaining before.
it seems to be constraint based, right? You need a universal set of all the possible combinations you can do with one hand.
But doesn't what Marinho said covers that though? Because Marinho said for every pair, because you need to have a pair anyway. So can't we just eliminate the pair and then check the combinatorial remaining?
The pair could also be used in triplets.
No, but that
Yeah,
doesn't matter. No, but that doesn't matter though. Because we are grabbing.
Hmm.
Okay, let me explain why that doesn't matter. Because this particularly combination mandates to have a pair. Regardless of which combination you end up, if you're going to have three, three of a kinds, or three straights, and one of the other, or vice versa, or all mix of anything, it doesn't matter. At the end of the day, you must have a pair, right? That means that if you enumerate all the possible pairs and we extract from them and then we do the combinatorial shit here, that's fine, no?
Well, technically, when you are removing the pairs, you are already doing part of the combinatorial analysis, actually.
Yes, you need to branch out in this universe where you remove this possible pair
Exactly, but that's what we were gonna do.
and look at all the pieces that are valid with that pair.
But that's exactly what we're gonna do, Magetta.
Well,
Uh, Technically, like, there's no difference in scoring between all the possible hands that you can make here, right?
um, there is the 7 pairs
No,
is
no, no. He's
more
talking
valuable.
specifically about this strategy. Forget the
One
seven
pair
pairs.
and four
Well,
melds.
no, in this case, no.
Okay.
That's the punctuation on that is not what matters. The
In
score.
that in that case, we can just look for the first hand that fulfills the condition, right?
The first hand that fulfills the condition.
Yeah. No.
Yeah, yeah.
Okay. I have another question.
Okay.
Um, maybe I am not understand. I am underestimating. I'm making an understatement of the combinatorial problem. But to me, isn't it just a combination of like, uh, do, how many three of a kind I have? So like, we can even use this function instead of the other one. So like, give me how many three of a kind I have, how many straights do I have, and how many pairs do I have. Can't we just use the results of those functions to make the winning condition? Or am I crazy?
No, you can't actually.
Okay, why?
Uh, because because
Ah, I know why. Because the calling them separately doesn't take into account that they can't be reused for multiple conditions, I guess.
yes, each tile must be part of exactly one group.
Okay, okay, that actually makes perfect sense. That actually makes perfect sense. Uh, okay, so now we do list comprehensions, right, on the pairs.
Least comprehensions on the pairs. Why?
Well, because we're going to iterate through each pair, right? And then do the how many sequences and straights can we have? Oh, straights and three of a kind we can have.
Technically, you should do not really a least comprehension.
Oh, we
It's
should
more
not do the
like
keys because you want to do use minus, right?
no, we do use the keys. It's just we're going to use
No, 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 but we need to remove them from the universe, remember?
no,
From the
yes,
hand.
but you are listing the keys that you can make pairs with, right? So for each such tile, you say, okay, I take the hand, I do the hand minus the tile with a count of 2.
Yeah, but why are we removing the values in that case? It seems more useful to me to just have the
We're removing the
smaller.
values because that's how we keep track of the tiles that have already been used for the hand.
That doesn't make sense to me at all. I'm gonna change my question. Aren't we gonna pick the hand and in each iteration of the fold, whatever, we're gonna grab the potential pair and remove the potential pair from the hand, and then do the analysis in there.
No, we're going to make, for each potential pair, we're going to make a separate hand without the pair.
That's what I
And then in
just
each
said.
of those hands, we do the analysis. But
I just
for
said
each
that.
step of the analysis, you have to. Yeah, that's basically it, actually.
Yeah, but you said what I said. I'm confused.
Like, you're not going to fold over just a sequence of pairs, actually. What you're going to do is do a nested fold, in fact.
No, no, no. I'm not saying it's gonna be only one fold. I'm just saying that we should. Man, I'm just gonna type it down and explain because I think you said what I said. We don't. We should not remove the keys. That's it. We should not remove the values because we're gonna pick these pairs and later do minus on the hand.
Well, yes, but you're not going to do minus with the number of tiles that you have. You're going to do minus with just 2.
What? No, 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 no. I'm gonna ask the same question differently. Let's say this. I have a pair here, right?
Yes.
When I'm about to iterate to identify the potential sequences in three of a kinds, I'm gonna start, I'm gonna eliminate this, right? Because I'm assuming I have this pair.
That's the easy case. The critical case is actually the other hand below this one. You see where you have the tree of tile character 6?
Sure.
You're not going to remove all three, you're only going to remove two.
Ah, because you're not doing equals equals, you're doing at least true.
Yeah.
That makes sense. Now I am convinced. Okay. Okay, so now we're gonna do the double fold, essentially.
Uh,
Do we need the members of the everything else? Well, we do. Actually, we do. So we're not gonna do this. Okay, so let's fold. Let's fold. Maps, fold, maps, fold. We're gonna have something in here. What's gonna be the accumulator, and what's gonna be the other thing? The other thing is gonna be transforming the list into a map, right? Back, but with the value true there. So do we have? Do can we transform a list into a map easily? Is there a convenient function to do that? Or we can just fold it again, I guess. So lists fold, fold left. This is gonna be an empty map, and this is gonna be the pairs. And in the lambda, I'm gonna have a pair, and then we're gonna make and the accumulator, and we're gonna make maps. I forgot. How do you insert? Put key value map. Okay, maps put. The key is pair, and the value is true, and this is the ACC, and this returns a new map. Okay, so now we are transforming it back, right? What's gonna be the initial accumulator, Marinho, of the outer fold?
of the outer fold. Hmm. If we just make this using folds, that's actually going to be pretty complicated, actually.
Okay, what do you suggest for us to use?
Hmm. Okay, this is gonna sound crazy, but what if we spawn a few processes?
Now you have it's literally that thing, that meme of like, uh we have one problem. Then let's do multi-threaded. Now I have two.
No, 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 but it's been the beam, so it should be easy. Just as easy.
Because here's what I'm thinking. If we're going to do, this is basically a search problem, right?
Yeah,
Essentially.
yeah.
Um,
Yes.
if we're going to do a search problem, that means we need to keep track of the of the search space, essentially, right? We could make a very complicated accumulator to keep track of that, or we can break it apart using a queue, and a process has a queue built in, right? That's kind of where what I was thinking.
Wait, so you want to? What do you mean by? You said a few processes, right? So are you gonna do only one process or multiple processes in there?
Well, technically it would be one process each time you call this function.
Oh, but how many times are you gonna call it? Are you gonna send one pair to one process?
No, no, the processes are not persistent. They'll just be ephemeral to help you compute, essentially.
But that's not what I asked. I'm trying to identify how many processes are gonna spawn. Are we gonna send each pair to one process and then he does the combinatorial check and sends the answer
Uh,
back?
No, it would
Okay.
be just one process where basically the process is going to say, okay, I'm looking at this tile. What are all the possible ways that I can remove this tile from consideration, right? And for each such way, it will send a message to itself saying, okay, this is one way, this is another way, this is another way. And then it will just keep looping over its own inbox that will be fed back into itself until it can figure out, yeah, all of the combinations that we care about. And when you find the first one, we can say, okay, this is the one. I can actually ignore everything else because they are all equivalent for this particular purpose.
Wait a moment. I'm still a little bit confused. So you are we the this process, this magical process would be grabbing what would be receiving? Let's start with the easy question. So I want to call that guy the dealer. So what it would receive? Let's start with that. What would it receive, Marinho?
Mm,
First, it would it be a function that receives something?
would it be a function that receives something?
Maybe the hand and the pair, the
Well,
piece or the tile.
it would have to be. Well, if the state is gonna be kept in the mailbox, it doesn't actually need to take any arguments, actually.
Okay, so it is literally directly a receive.
Yes, it is literally just a receive. You're going to receive a tuple
Uh
which
huh.
has the a multiset, which is the hand without the tiles that we are already grouping, right?
Okay, so it's the hand without the pair.
Well, to begin with, yes, but then we are going to remove more stuff as we try to build up the hands, right? The
Okay,
the
what else in the
the
tuple?
the other thing is, I think it would be nice if we collect a list with the melds that we have accumulated so far.
So list.
So initially, it would be just a list with the pair that we removed, essentially.
That makes total sense to me. Magenta, are you following?
Sorry, I was reading something else. What is it?
Okay, actually, then we can explain it after we finish. We can continue reading that.
Okay.
Go, Marinho, go. I'm following.
I learned three more Yakos, by the way. I think we should stop on the fifth, to be honest.
Okay, so
No,
the
no, seriously,
magical.
there is one that I just saw a video that a guy did, like, the guy couldn't even reproduce it because it's extremely hard to get. It gives you a lot of points, but it's technically possible, but it's very rare, and he had to bring up a video of a competition of a narrator screaming because that happened on an event. It's like a very tiny chance, and it did happen.
Okay, anyway, let's focus in here
Anyway,
because we're in the middle of the thing. So go, Marinho.
Yeah, so basically the idea is okay, I have this hand, this partial hand, right? Because we removed some groupings already.
Yeah, I think that's a good name.
And we have this list of the melds that we have formed so far, right?
Yeah.
Um, Actually, there's a third item in the tuple, which needs to be the sequence of tiles. The sequence of tiles. Actually, here's a question. Can we just take like an arbitrary key from the map? Hmm. Like, is there a function that says, okay, give me the first key where the count is whatever?
Let's check. From list get is key iterator keys map merge new next.
Probably not.
put, remove, size, take, update, update with, values with and without.
Okay, so we probably will need actually a third item in the tuple, which
No,
is
no, no,
the
no. There is,
sequence.
there is, there is. It's called with, right? I think. What did you ask? Repeat, please, the thing.
Like a function that says, okay, give me an arbitrary key value pair from the map, essentially. That's not
That's
really a thing, right? Because that would be non-deterministic, I guess.
Yeah.
Man, Prolog would be so nice here.
We wouldn't have to worry with many of these problems, yes.
Okay, so since we don't have that function, we need a third, actually, a third item in the tuple, which is the sequence of keys that we are iterating through. Okay?
Can't we just use this iterator thing? Sounds like something you would want.
No, because that's next iterator. Hmm. Returns the next key value association in iterator.
Ah, it's an immutable. It's an immutable state monad. I see. So,
No, that would be fine. It's just
like, you grab the initial map, you pop something out of there, so and you get the remaining map, and then you keep doing that. We can just literally do this, no? Like, we pop something from the partial hand, we're gonna get the remaining hand and the key value pair.
that doesn't quite do what we want, though.
Hmm. Okay. What is the role of this? Well, not this one, but the ideal one, I guess.
Basically, I would want to be able to keep track of the keys that we have already looked at and just ignore those because we already looked at them, right?
Yes. Yes. Okay, so you want to see the previous keys, right? Previous styles, I guess. Right?
It would be more like next tiles actually, because we technically we have the sequence of keys of the original map easily at hand, right?
Wait, you want the sequence of keys of the original map?
Yes.
That should be an argument.
No, that's not an argument. That's going to be part of the initial payload when we construct the pairs initially.
Why don't we put here things that are changing, and then the immutable things we put as arguments?
Because we're going to be using the process mailbox for that.
Ah, that's a good reason. Okay, so you want the original hand, a partial hand, the melds in the previous tiles. Is that what you
No, no,
want?
no. I want the partial hand, I want the melds, and I want the next tiles.
Yeah, I don't follow. To me, the partial hand are
I
the next tiles. Go, Magit.
I I don't follow the next styles also.
Okay, go, Marin.
Uh, hmm.
The partial hand has the next tiles in it. It's the remaining hand. What are you talking about?
Actually, I think you are right, because here's the thing. I was thinking, okay, what if we need to skip a tile for some reason? Like, I don't have three of them, so I can't make a triple, and I don't have the tile before and after it, right? Well, in that case,
Mm,
that hand is already dead because you can't form the necessary groupings, right? You have a tile that doesn't fit, essentially.
I think it's better. Okay, so wait. I think it might be easier then for us to check if there is any possibility in the hand that disqualifies it for winning, right? If we flip the
Right.
approach, I think it's easier. So,
Yeah.
actually, that makes a lot more sense, Magita, because we don't care. We don't care of which way you're gonna win. We only care
Yes,
if the criteria is met.
exactly. So and then we can exclude and make it easier for the subsequent checks, right? So for example, you could check first if there's only, which would be kind of like a double for loop. Think of a procedural code. So double for loop, checking each value against each other in a pair, right?
Hmm.
So that's one case. So you eliminate that. Okay, so there are no pairs. Uh, there are no pairs at all. Therefore, the hand is already invalid. You see, there is one pair. Good. Proceed.
Okay, so Magetta wants to reverse the logic, Marin. Instead of us trying to find ways of you to win, he wants to exclude the ways that you can't win. And if that set is non-empty, that means that you can win after.
Because you don't need to know all the possibilities, right? Because that would be hard.
It would also be pointless.
Yes, I mean, not really. You can kind of show that on a UI, for example, but yeah.
Man, that's tough. Okay, so how can okay, which let's try to decide which way is easier because trying to find the first solution seems hard to me. Maybe Marinho has already the solution there and
Trying
he's
to
not
find
telling
one
us.
solution that does, trying to find one falsifiable case, I think is easier.
Yeah, that's where I'm not sure. Marinho, what's your opinion?
Uh, well, I think.
Man, I don't know how Magetta got to that conclusion so fast. I'm not sure.
I can think of an algorithm that is very simple to do that.
Okay, what do you have in mind?
So, as I said, first check the pairs. If there are no
Okay,
pairs, it's already disqualified, right? So,
right.
break. If there is one and only one, so, and then you have two checks to do, right? If there's seven pairs, then automatically true. If
Yeah,
there's
we
one
already
pair,
implemented that one.
if
Hmm.
there's one pair, proceed. And then you need to check only the other four melts, right? And then it's again just go checking one by one with the possible pairs in all of them, and they must be four as well. So the counter must be four for the melts.
Yeah, but what Marinho, but that's the problem, right? Because you said we need to find how many melts. That's what Marinho was implementing, no?
With a double for loop, that's just what I'm saying. So you pick one piece, look at all the others. You don't need to. You can discard, right? In that case,
Hmm.
because you discard select first by the group. If the group doesn't work, then you check the sequence. If the sequence doesn't work, then it's you don't add up on the counter. That's it. Is that what Marin was proposing?
Uh,
Uh,
Marinho was proposing counting the melts, like identifying melts. He was kind of going
Yes.
with that. But that's a problem because there is a combinatorial ways of creating melds. That's kind of the big problem in here.
Well, wait. There is one way to combine the possible melds, and that for that you're going to require the sets of melds, and the other is you need to fulfill four. If you can make four, excluding pieces, so you can check linearly. Actually, not linearly. That would be. I think that would still be a polynomial.
Wait, I have a question. I just had an idea. Am I going insane? Because I just got to the conclusion that each piece has only four possible groupings, no? It can either be 5, 6, 7, 4, 5, 6, or 3, 4, 5, or 5, 5, 5, 5. Am I crazy?
uh, well, technically, you.
Each piece only has,
Four
well,
configurations.
That's only thinking of the suits, right? That's not thinking of the winds nor the which can only be equal in the
No,
dragons,
no, no. Of
right?
course, we can do ifs for the things that are not
Yeah, yeah.
numbers,
But
but
in those cases with the suits, there's only two possible cases for each one of them. Actually, three,
I count four.
which is four. Let me
Yeah,
see. So
yeah.
three
It can be
repeated,
Three
five, five,
yeah, it can be
five,
repeated.
and then it
Yes.
is one, two. Oh, I see, see. Yeah, actually, two, three, five. No, sorry, two,
Three,
three,
four,
four,
five.
five.
Four, five,
Then
six.
it's actually a window of two, right?
Yes, that's why it's three possibilities plus the
Yeah, yeah.
repetitions.
No, no, that's right.
Yeah, so each piece that after we exclude the pair, each piece has only four possible combinations. The problem is that this doesn't tackle the repetition, right? Because let's say that you have a 3 and a 4 and a 6. Like you have a full 2 to 7, let's say. The 5 can participate in three different configurations, right? That's what Marinho wanted to exclude. That's why he wanted to use the Q, because he essentially would do recursion, but instead of passing the accumulator, he would use the beams message process to do the accumulator for us. But it's essentially recursion, and he would branch out of all of these possibilities and then do something with that. We didn't reach that yet, but
yeah. Basically, the idea would be okay. I'm iterating over the tiles. That's why we need the sequence of next tiles. For the current tile, what are all the possible ways that I can eliminate it? I can make a three of a kind. I can make it part of a sequence in three possible positions,
that's it.
and I will send a message to myself, doing every one of those possibilities that I can do, basically. And it could be that there's zero because like you can't make any melds with that tile, and then it's basically over, right? For this particular branch that we're exploring. It could be that you just have three and you don't have the adjacent pieces, so you just have the three of a kind. So that would be the case where there's one message being sent. It could be that you have two different ways to make a sequence out of this, like in the middle and at the end, for example. And
And each branch would exclude that combination to the next iteration, right?
yeah, each branch, to create the message that you send to yourself, you remove that combination from the
Yeah, you put
from
it inside the
the
melds, right? You remove from the partial hand and you put it in here.
yes, and then you eliminate the tile from the sequence of next tiles because you already looked at that.
Okay, Margit, did you follow that?
That will be infernal.
No, it isn't. That's the cool part
How exactly, man?
because the actually let's write that. Let's write this. So this is a list, Marinho. Is that what you want?
Yeah, it's just the keys of the original hand, essentially.
We can pattern match on this, right? So list or cons head. So this is a tile, and this is next tiles. Okay. So here's what we're gonna do, Magita. We're gonna grab the tile because this is essentially the lookup thing, right? Uh, we grab the tile. So let's start. Let's say it's this way. Then we're gonna ask, okay, assuming the partial hand, what are the possible combinations out of the four candidates that I can make? For example, can I make a three of a kind with this one? No. So I don't. I'm not gonna recurse with myself with that. Next, can I make a 2, 3, 4? No. Can I make a 1, 2, 3? No. In the case of 2, that's it because he doesn't have he's not in the middle, right, of the numbers. Well, middle, let's say. So we actually stop the recursion in here in this case, and then we go to the next one. In the case of the 3, can I make a 3 of a kind? No. Can I make a 2, 3, 4? No. Can I make a 3, 4, 5? No. Then you keep doing that until you reach a point that you have multiple potential configurations. Let's see if this guy is fucked, right? This guy. This guy is fucked.
Yeah, he doesn't win. Like he
Yeah,
just doesn't.
yeah. So let's grab a guy that is actually doing great. So uh,
5, 6, 7,
where is the 5 6 7?
or well, just create. Oh, you're creating randomly. I would say set up a hand. That's probably easier to
Oh,
test.
actually, this 6, for example. This 6, when we reach there,
6,
we're not
9.
gonna be able to do 4 5 6 or 5 6 7 or 6 7 9. So all the straights are gone, but this guy can actually make three of a kind. So what do? We add this potential meld to the list of melds. We recurse the we do the exclamation mark. We put into the queue a universe in which this meld doesn't exist anymore. And we're gonna do that
Because
for all the potential four candidates of melds.
and if we ever find a piece that we cannot eliminate, we say, yeah, this doesn't fit anywhere, so we can actually stop here, return false from to the well, send a message to the process that created us,
And kill
saying,
ourselves.
okay, yeah, return false to that original process, send a message, and then just die essentially because you found a piece that you cannot eliminate, so that means
Not eliminating a piece is the break of your double for loop, Nugget. So if you find a piece,
Eliminating a piece,
yeah, it's
yes.
not being able to eliminate a piece from all the not finding any of the four paths. For example,
Mm-hmm.
this one. This is already the condition, right? Because this can't be three of a kind. This can't go 1 2 3. That's it. This process, the dealer already says, okay, this guy's fucked. Just returns false. We only return true if this is empty, right, Marie?
yeah, if you can empty out your hand completely, that means you have made 4 melds essentially.
Yeah. And that the combinatorial is kind of hidden because we are basically putting to ourselves, right? When we have, for example, let's say that there is a potential piece here that has all the four candidates. What do? We just put four universes to the dealer in the queue.
Mm, I guess technically we could also just do the nested folds, but
No, but
the
this
state
is more
management
Erlang. This is more Erlang money.
it is basically the difference is if you use a process and use the message queue for that, that's a breadth first search. If you do recursion, that's depth first. Do we care about the difference? In
Which
this
one is
case, I
faster?
don't. Well, they should be roughly the same speed because this is a finite search space, right?
Yeah. Anyway, Mageta, did you follow the strategy? Does it make sense?
I'm writing the code here, but I think yes.
You're writing the
Uh,
code. What do you mean?
I'm trying to do that in Elisp, to be honest.
Why would he not be?
Why would I not be? It's easy to test, man. It's my new scripting language.
I
Uh,
have a
I mean,
question.
it's already.
Don't we need the PID of the counter in here?
We would need the PID of the process that spawned you. Yes.
So in here because it is immutable. None of these are immutable. Well, immutable in a sense that you're gonna keep changing them every time, right?
Right.
So if okay, here's the deal. This is the let's do the base case first. So if you have something, and then cons actually empty in here, yeah, empty. So this, if you have that, we just do this PID false, right? How we do false in the how do you do false in LFE?
hashtag? Isn't it hashtag F?
It's
Or is that
quote.
scheme? No, that's the
That's,
scheme, right?
that's actually scheme. It's quote. It should be just quote false because, fun fact, the booleans in Erlang are literally just atoms, true and false.
Of course you know about the booleans in Erlang.
Okay. Let's continue. So if you have the
Okay, I did the thing to check the the three equal pieces. That works. So I can check a hand with three equal pieces. So I just
No, but that I already
recurse
wrote as well. It's in here.
the three equal pieces.
You grab a
Three
hand
of a
and you
kind.
grab a hand and you just fold over the counting if because you have multi-set, so you already know how many in there.
But
You just
wait,
check if it's
you're not
sufficient.
checking that alongside the other possibility, are you?
Not yet. I'm gonna call this inside the dealer, essentially.
Okay, so I can do that with these.
Anyway, so I think I'm doing wrong syntax in here. Can somebody help me?
Use,
So is this correct in terms of the parentheses, Marin?
Just give me 1 second.
Okay, I have a sequence of three, true.
Um,
I think.
okay, so now I need to grab all the potential. I need to
Sequence
do
of
a lookup.
three. True. It's false. If I change this to 6. New. Perfect. Okay, this works, but I'm not sure how to map this to LFA.
Wait, you have the code already there?
Yes, and I had to use the Como Lisp trash.
No, just send the code over. I can translate it to LFA, no problem. But I'm very surprised. Did you do your algorithm or the one Marin was suggesting?
I was doing what I was thinking is,
Okay, let's see.
do I have a Lisp on Discord? No.
No, but you have Lisp. You can just put Lisp
Ooh,
here.
this code is garbage, man.
I'm very surprised if you managed to pull that off without difficulty. Let's see. Maybe we are
Uh,
stupid, Marin. Maybe.
the formatting is garbage. I don't think it's that pretty though, to be honest.
No, but if it does the job, I think Marinho's is the best way to do the job. But you are making a more a stronger claim. Let's see. So this is the code. This is the code.
I can explain. There's like some auxiliary trash that I'm using.
Okay.
So
So let's start with the cond. So the first thing that you're checking if you have four melds, because if you do
yeah,
and
so
you
the
don't have
base
any more
case
tiles,
is if I have 4 and no tiles are like
left.
left, then that's just true, right?
If you have more than four melds or you have less than three tiles, you return new.
Yeah, that's
Otherwise,
false.
you do
Then I need to check
you grab the
the 3.
first
Yeah.
and then you do a war for three equal pieces.
Yes. If there's a 3, then I check that and recurse. Simple.
Count tiles. If it okay, so if you have more than three, then you have oh, you're calling yourself.
So otherwise, you try to remove uh the 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 sequence of 3, right? One from the sequence of 3 and recurse as well on the same suit.
Okay. Otherwise, you're doing the sequence of three. So you have a function make sequence of three, which essentially grabs the tile and what
That
creates
function is basically just a
one, two, three.
it returns the potential sequence of
But
3.
there are three potential sequences.
Yeah, so it will generate the so what you send to it is a single tile,
Yeah.
and it's going to loop over the range that it's possible to generate
So
one.
if this is a one, this is a one, two, three. If this is a three, this is
Yes.
either a two, three,
So for
a one,
example,
two, three.
3m. So 3 month, right? So it's going to be 3 4 5, for example.
Okay, so
So it
if this is a
works with
three,
the
this
range of
returns three sequences.
it return 3
Sequences.
sequences.
If this is a tile three or four.
Returns 3 sequences, yes.
Yes. Okay. So you check if that,
Let me check one
but
thing here, by the way.
there if there is
This
something in there.
false.
Then you check if for every sequence of threes.
Wait, I think there's a bug. But keep going. Is there a bug?
Oh, you're checking that the member. Yeah, this is not gonna work because it's returning a single sequence. I think.
Yes,
My
it's. I
mistake.
only check for one sequence,
Yeah, you need to
right?
loop over
I would
again.
need to do a range, yes.
Yeah.
Although, wait a sec. Wait a sec. Oh man, wait. But my counter is different because wait. Can you give him one case where that would fail? Let me think.
Which
Uh,
case? Which fail are
it
you
needs
talking
to be
about?
a case that overlaps, right? That two sets overlap with each other. So
No,
let me
that's a three,
see.
a four. Doesn't matter.
It needs to be with three melds overlapping because there's three elements, right? So it needs to be three. Let me put three, three, four, five, and then I do
Martin, what
six,
are you writing there?
7,
Uh, I'm just trying to write out the idea I had, and just for simplicity, I
8,
think I'm just going to do the depth first strategy, so like recursion, nested folds essentially.
9.
But
So that would go.
work in progress, work in progress. Are we recording, by the way?
Yeah.
Okay.
Um. Yeah, I think to fix Mageta's code, although I don't
eh,
know if this is counting to the repetition problem.
I don't think it's a problem.
Oh, it is a problem.
In this case, in this code, I don't think it is because it's counting the possibility from a fixed point. If it was looping over the others, the only possibility that I'm trying to reproduce that I think might be a problem is if it overlaps with three melds. Then that would cause the thing to get one more possibility
I
because
don't
you
know.
don't have.
I don't know what you mean by overlap of three melds. So.
I will try to come up with an example. Give me a sec. So three.
What a game Mageta chose.
You guys willingly chose to do it, so now suffer. It needs to be 356. But 356 is too large already. I have to go all the way to. No, that's fine. So let me put 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here I'll leave 2, 3, 4. Okay, so eval buffer. Does this work? True. So it does work. Is this right? I'm suspicious now.
I don't know what you were trying, so I can't tell.
Uh, because like here's the problem. Like it seems like for you to be absolutely certain that you will need to generate all the valid paths, right? That you need to go with. So my make sequence of three thingy, if you send like two, it will just give you like one possibility, like 2, 3, 4, right? But there's more. There's like 1, 2, 3, 2, 2, 2, right?
Wait a
Actually,
moment.
no.
Wait, wait,
Sorry.
wait,
Sequence
wait,
of
wait,
three.
wait, wait,
Just
wait, 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 wait. You are iterating,
mm,
boys. I think Mageta showed me something. So, uh, Marinho, can you look at my screen to confirm if I'm going crazy?
Um,
all going
I'm looking
crazy.
at your screen.
I'm starting to consider that maybe Mageta is completely right, but I don't know. Maybe he already figured that out and he just didn't explain to us. But you don't need to count all the you don't need to do all the four possibilities, man, for each piece. You only need to do two, which is exactly what
Yes.
he's doing. You see?
Yes. You
And
only
why?
need two.
Because doing the recursion, you will inevitably encounter the other sequences. Because, for example, let's say that I have
That's
a
why I said the counter.
let's
By the
say that
way.
we have a you have a 1, 2, 3. Let's say that you have this actually. Let's me actually type this down. 1, 2, 3, 4, 5. Okay. So what are the possible sequences we're using three? 2, 3, 4, 1, 2, 3, and 3, 4, 5. Agree?
Yeah. I mean, you
But
got it. I
Yeah.
think there's still a problem there, but go on.
But if you always assume this to be the piece that you're currently iterating the first, when you go to the alternate universe that
Hmm.
one was being removed, and you do 2, 3, 4, and then when 2 was removed, you do 3, 4, 5. You're already counting all the
You're already
potential sequences
taking
you're
into
using 3.
consideration the other tiles, yes. You only look forward. The problem I have is think about this. If you have the same tile being used in the three different sequences, then you have three potentially valid counters in the recursion. You see? For
No,
the
yeah, you have this problem because you're using one counter, right? We don't because we're gonna use processes anyway. Like, is that what you're saying? That you doing the recursion, you're gonna like keep track of the counters, the different counters?
yeah, because if I send like for example, I'm passing down the the melds as my counter, right?
Mm-hmm.
So if it's more than four, then it's new, right?
Yes.
So it will overcount the values. I think I need to come up with a case to prove that. I don't know if that actually will happen, but I
Yeah.
think that can only happen if it's three. If it's a if it's a shared value in the three suits.
In the 3 suits.
Yeah, but in any suit. Sorry, like in the
No, you're
the
talking about the 3
triplet.
here, for example.
Yes, for example, that you have multiple possibilities, right? So that will overcount, I think.
Why do you think that's true though?
No, man, because I'm reducing. Okay, I think, man, I think this is correct. That's
Yeah,
it.
yeah, that's what I was trying to say. After concluding that you don't need to take into consideration each combination per tile, but you can just move forward,
Yes,
that
you
makes the
can only
entire
look
thing
ahead,
easier.
and but the thing is, the gotcha is that you need to reduce and look into the recursion, right? That's the only gotcha.
We need to reduce and look into the and put that in, wait, repeat that last part.
You need to define the reduced tile set, right?
Yeah,
Removing the
this
ones
is
that
the
you have
next
already
tiles.
counted.
Just okay, let's do
Yes,
the
yes,
mapping.
this is the
Let's
next tiles.
let's do the mapping. So the remaining tiles.
Yeah, in my case, I called reduce, but next tiles.
Wait a moment, Marinho. I think he Magetta simplified because you have two accumulators, right? The hand that is remaining and the tiles that are still to be looked ahead, right?
Hmm.
Yeah.
Magetta is starting with the full hand, and he keeps
Hmm.
removing the
Yes,
he
which I
keeps
think is easier.
removing the ones that are being used, and the next, and he just have one accumulator. He doesn't need two. You see?
Which can be dangerous, but I don't think that that is a worry for the combed. You see there
That
the melts for.
that works, but only if you assume that the keys in the map are sorted.
Yes, you need to sort. Yes.
Oh, we don't have that assumption. That's why Marinho
I
made two accumulators.
Yeah.
Okay. Damn. Okay. Okay, but Marinho, I think we can like if we want to go with your idea, like because I think what
No,
Magetta did actually works. I think what he did actually
I
works.
think it should be easy to add with two counters as well. Like you just need to follow the same recursion step, but with two, right?
Yeah, but one of them you're gonna do the remove, and the other one you're gonna do nothing essentially,
You might
right?
have more iterations, but that's the only difference, I think. Because you can't assume it's sorted, right?
But we can sort. It's 14 tiles, bros.
I
Yeah,
mean,
like
you can't really sort the map, but you can sort the sequence of tiles.
mm,
Oh, but then we're gonna lose the values, right? We are kind of using that.
No,
Actually,
you
that's a
just
good
sort.
question. How is Magetta solution handling repetitions?
what do you mean repetitions?
What if you have this? Whoops.
333? Oh, that's just the same.
That's just the same.
Then that's the cho. Yes, that's the first case of the or, right? So you already
The
check
first case
count
of the
tile.
or? You mean this?
Yes, it's the when there. Like first 4 3 equal I even left a comment, man.
No, but I said this isn't. These two threes are they won't go into here.
What do you mean? This Oh, the first two 3 3 3.
Yeah,
That
you
one?
have. Yeah, you have one, two
Oh,
threes,
in
one,
that case, you
four.
can't form a meld, right? Oh no, you can because of the five. Oh, that's true. Um, can you break it down like in groups? That's probably easier to. No, I mean like not lines, man. Break down in groups, like
In groups. What do you mean?
yeah. Put each group in of three in a row. That's probably easier. One, two, three in a row, and then three, four, five, and then five, five, five. Right?
Yeah. Because here's the thing. This is a meld. One, two, three using these three. One, two, three using these other three is also a meld. These three, four, five is a meld. These three, four, five is a meld. And then there's also the combinations with these fives.
Three, three with five, 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 which is already a meld as
Yeah,
well.
this
That's
is
the
also a
count time,
meld.
which is just a Como Lisp count, by the way.
Uh,
By the way, you're assuming you need to take into consideration that kind of tile two, right? It's not
no, no,
just
no. But
one,
I'm
two,
no,
three.
no, no. But they are already separated by the kind. Let's just all the examples here are assuming all bamboo or all whatever.
All bamboo, okay.
Yeah.
So,
But the problem comes when you have this type of situation, right? Because if you have one, two, three,
mhm.
you can use all those threes for that and not have one, two, three. You can use all those threes for that instead of three, four, five. But you can then have a pair if you keep the one, two, three. So, uh,
Oh
man,
wait, my
fuck.
uh.
This
So
is
wait
so.
on that on that code it would check for the repeated, right? So it would first see the. Oh man, this is mind knotting. Like what the
Yeah,
heck?
it's very fucked. Okay,
So
I
it tries to check the 333, right? So that's the one it finds first. So
yeah, I
then
think we
the
need to do this
remaining would
filtering of
be.
removing the pairs. Okay.
Can you paste? Can you? Let's go step by step. Let's do a table, like a process in our heads. So can you copy everything and put like one, two, four, and I think yeah, one, two, four, five, five, five.
Um,
Just copy paste and
okay.
remove the threes.
Remove the threes on
Yes,
this.
yeah. So this will be the remaining, right? So the next tiles.
Yeah, yeah, but here's the thing. Wait a second. Before we go into this, because it's going to go into a rabbit hole, I think to get around this problem, we can do the first strategy of removing the pairs. Go into the universes that you already removed
Hmm.
pairs. Because that simplifies this to this.
Oh, but wait, that was already with pairs removed, right?
Oh, oh, okay. No, but that's not true because if we were in a universe that we
There's
have,
one, two, three, four, five, six, seven, eight, nine, 10.
well,
10 pieces there.
I didn't put all.
Yeah, I mean, you should, right?
Is that 14?
You need four melts, right? So you need 12. You had 10.
Okay, one, two, five, six, 10, 11, 12, 13, 14. Okay, so the first thing we do, we go to the universes that we are iterating through a pair. So, for example, let's remove this pair. And then we do the combinatorial shit in here. And then in the next iteration, we remove this pair. And then we do the combinatorial shit. And then in the next, we're going to remove this pair and do the same. Because we know that you're going to have to end up with a pair. That's why we are doing the simplification. Not only to remove the combinatorial explosion, to reduce it, but to also get around the get to simplify this shit essentially. Uh, okay. Anyway,
I
let's.
think
Okay, go.
I think it would work. It would just get one.
Let's remove this pair for example. Let's move the 7 7. Let's suppose that
Okay,
we're
so there's.
iterating.
Let me see. Wait, so there must be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's one more tile. Remove the 9. Yeah, so now it's correct.
This is 12.
Yes, this is 12.
1, 2, 5, 6, 10, 11, 12. Okay. Okay, so now we do this algorithm in here. We
So,
check,
okay.
we first
Oof.
check. We do have four melds or
Give me a
we are
sec,
out of
buddy.
tiles? Sure. You're still writing in there, Marie?
Yep.
Man, assume they are sorted and assume that we're not gonna check for the four possibilities. You're only gonna go forward and repetition. Just do that. And then you will recurse. Using the processes or not. You can do accumulator or whatever. I think you're gonna end up with a code very similar to Mageta's. I just don't know about these conditions on the top. Because maybe the condition that we care is just the tiles being empty, which is what I was doing. But do you agree, Marin, that it's easier to assume that they are sorted, and it's easier to assume that to go to the with only moving forward of the sequence?
Yes, I do.
Okay. And then you keep accumulating that. Yeah, if we're gonna do that, we don't need the partial hand anymore. We can just use next tiles. So then it becomes like this. It becomes like this. Actually no, it's the opposite. This is empty, and the melds don't matter. And then we can
I'm
change my
back.
function. Okay. Anyway, let's
So
go.
let's do the thing. So first it will check for the 1, 2, 3, right? And then it checks. So it leaves a remaining of 3, 3, 4, 5, 5, 5, all the fives, the
And the
four
6 8.
fives, 6, 8. And then it tries later the 3, 3, 3, right? And
Wait, it tries later the 3 3 3. It shouldn't try the 2 first now?
because it already removed the 1, 2, right?
But that's a problem because there is also 2 3 4.
Yeah, but there is one that is not on the list, right? So it's windowing. That is true.
No, no, no. You are partially correct. We need to go into a universe in which we did 1 2 3 because otherwise the 1 is going to be remaining and we break the recursion. So we need to go there. But we cannot remove the 2. We need to do 2 recursive, like, we need to spawn a universe in which 1 2 3 was done. And then we need to
To
spawn
check
another
the
universe that 2 is there.
2, 3, 2, 3, 4. Yes.
No, that's not true because in the universe that we did 2 3 4, the 1 is remaining and we finished. You can't win.
Oh, yes, that's true. True, true,
So
true,
we
true.
need to go to 1 2 3. So da, by, and by.
Hmm.
Then we do this here, and then I need to try to allocate these two threes. So there is 3 4 5. We can go to that universe because otherwise we're gonna have a
Oh,
langing
there's
3.
the other universe too, which is to check. Oh, let's do one per universe, right? So I think this one, the first will fail.
It will fail for sure. So that
Yes, this
means
will fail.
that we need to go here, which means that this is hanging when we finish.
Yeah, but the next might work further. So you're gonna do 1, 2. Uh,
No, no,
you
no.
first
We
check
already
for 3, 3,
excluded a
3.
pair. We already excluded a pair. We can't afford pairs anymore.
Uh,
Like, I think this works. I think this is actually way easier than we were thinking before, because the universes that we leave pieces behind, they don't matter for what we're doing. We need to allocate a piece, right? We need to. I agree, Magenta? Magenta?
yeah, I'm thinking, man.
Because, for example, if we don't do 1 2 3, we're gonna have 1 and 2 alone, and that already means that you can't win. So we must go to this state. We can't do otherwise. We must.
Hmm.
However, let's suppose that this was the situation. Now we have two universes. You see why? Because there are two ways to get rid of those threes. Well, these
Yeah.
three. We can either go here and then we go to this universe, or we go here.
Yeah, the first universe where you try to this will fail, right? There's no possible
Yeah,
hand,
these will fail.
but the first hand it will try is like 1, 2, 3, and the remaining, and then that fails. And then it tries 3, 3, 3, that also fails. Four,
Yeah,
five, six, that also fails.
yeah. But
So
the
in
three, three,
none
three,
of
assuming
these,
there's a fourth here, right?
yeah.
Yeah. So if
So
you must go to
in the
this
first you can
universe.
only do two.
Yeah, man. We must. Okay, so that's what my team is probably implementing right now. You must check for the ones that are doable to continue, because if you have
Yeah.
hanging pieces, you can stop the recursion right there.
Mm-hmm, mm-hmm.
So this is what an optimization that this code could do, right?
Okay, we can check a tempai. That's
Wait,
cool.
what is that?
And yeah, it's the term for the condition, right? It's a tempai.
Okay, anyway, I think I gotta go now. It's already 15 to 11. But man, this was very fun, and this was very unexpectedly combinatorial. Like in the beginning, I thought it would be way worse, but the fact that you can literally break the loop as soon as you encounter a hanging piece, that makes it way easier. That makes it way easier. Marin, do you agree with what I'm saying here?
Yes.
So if you have this hand, for example, well, let's eliminate this 8 for the sake of having 12 in here. So if you have this hand, for example, you must do 1, 2, 3, right, Marin? Because otherwise that one is going to be hanging.
Yes.
So you do this, and then this is the only scenario that you branch off.
Yeah, you
Because
can
you
either do
this, right? You can
or three,
either
four,
have
five.
this or 3, 4, 5. Also, that means we can't have pairs, right? You can't have pairs because we're already assuming you have a pair excluded. So you can't form pairs. That means that you can always form triplets. So that we always need to branch twice at maximum, right?
Hmm.
Either you have a triplet or you have a sequence. And we always move forward. So it's always 3, 4, 5 or 3, 3, 3.
3, 4, 5 or 3, 3, 3.
There's no way around that. Or this tree is going to be hanging. So we always go at one branch further or we splice in two. That's it.
Okay.
And
We forgot about Oron, which is another condition.
this is exactly what Magetta is doing, Marin. What is the maximum amount of call that the recursion calls? Two. So yeah, so maybe Magetta is a genius. Maybe, just maybe.
Maybe. I I think that's more of an accident than actually. Wait, what is it that you're saying?
I was saying the following: that instead of going to a crazy, potentially uncertain amount of combinations, branches that we can call the recursion, in this particular example, there is no branching with the one,
Yes,
right?
it already tries to
It
eliminate
always
that.
goes further. And then we also eliminate the two because there's only
Yes,
one two in
because you
here.
can't make a meld.
The only case, well, this three must also
Hmm.
go. The only case that we need to branch is if you have
Um.
the first piece, that piece is a piece that can do a
The
triplet,
only cases that are true, yes. So
or
three, three,
the
three.
3, 4, 5,
Yeah.
and that also means that we
Act-
at most we branch twice.
Actually, we can eliminate the 3, 4, 5 from consideration here because that will leave the pair of threes hanging, right?
No, but you don't know that. Maybe there's another 3 in here. You don't know.
No, no, but you'll know because you are going in order, right?
Yes, it goes in order.
That means if you reach this
Ah.
point and you have a triple, if you have a three of a kind of threes, that
Mhm.
means you either have three sequences that all start at three,
Yes.
or you have just the three of a kind.
Uh,
I
Three.
didn't follow
I need
that
to
last part there.
translate Marinho's terms, man. Wait. Three of a kind.
Is the
What is
triplet? Is the same? Like 3, 3, 3.
right,
This
right.
is a
And
three of a kind. and he's calling, well, the sequence is the sequence. I didn't follow the conclusion of that, Marinho. Could you repeat?
I don't follow too.
Because those are the only ways where you can completely eliminate the trees in this case.
Oh, you actually
Yeah,
optimizing this away then, even
but
further than my Magetta.
no, because wait, let me think. So the first meld you can do is 1, 2, 3, and then that leaves you the remainder of the 2 3s, 4.
Well, actually, you need the six. Sorry. What
Okay.
what Marinho is saying? What Marinho is saying is, if
Hmm.
you encounter a situation like this,
Yeah.
you can automatically cut some universes because you have, well, in our case, we know how many there are of each piece.
Actually, in this particular case, well, the only way to completely eliminate the trees is actually to say, okay, there's triplets of trees and
And three,
there's a
four, five.
sequence 3, 4, 5.
He can do
Hmm.
those predictions, Magetta, because he's not using a list. We are using a multi-set. You do
Oh, I
follow?
see. Yeah, yeah, I see.
So he can literally do 2 steps ahead and say, okay, actually, to not have any of the threes hanging, you must do
Hmm.
triplet, 3, 4, 5.
Yeah, yeah,
And
that's
that
very clever.
cuts the iteration that you would be doing yourself.
Yeah,
Damn.
man,
Uh,
this
Best
is a very sophisticated algorithm. Like I'm.
well, well, if you get the data right, everything becomes easier, right?
No, yeah, your idea of using multi-sets is already going like premature optimization route, which I appreciate because you already could foresee that in the to today from
It's
last
not
past
really
week.
premature optimization. It's just putting the data in a structure which is which correctly expresses what we want to capture.
But I would bet that last week you wouldn't think of this thing that I just explained.
Isn't that the point of the relational model, by the way?
It is.
Wait, I didn't follow that question. What is the point of the relational model there?
It's to represent reality, right? And assuming that reality is not insane, then it should be easy. Things should follow as truthful as a consequence of
No,
that,
but yeah,
right?
yeah, that's true, but that's not what he meant because what we have is a multi-set, not relations in here in this case.
I mean,
No,
you
but
could
I think
work.
that the idea is the same, right? That if you're modeling your data, trying to
Properly.
represent correctly, yeah, properly, trying to represent it correctly, then the things fall
No,
into
I
place.
completely agree with the take. I'm just saying, I'm just asking Marinho if last week he was already foreseeing this consequence.
If he saw, man, Marinho is a complete genius.
Yeah.
I just figured, okay, we have a hand of tiles. We actually don't care how the tiles are arranged sequentially. That's a display concern. So we don't need order. We need to be able to efficiently remove tiles because otherwise checking the combinations will become very painful. And that's like, well, you have to use a multiset because
No, no,
it's
no.
not really an arbitrary map
Using
because
those premises, you're gonna conclude a multi-set. But my question remains: when you suggested that, did you foresee these effects that we just went through? Because I
uh,
just seen this now. Like I just saw this 30 seconds ago.
not
That we
really.
can we can do two moves at once because we are using a multi-set. Because
Well, not
In Magetta's modeling, he's using a list. He can't do that.
There's there's another condition that I'm seeing, which are Yaku based on triplets and or quads.
Wait, you can have quads?
not
Apparently, there's a condition that you need to have quads, like 1, 2, 3, 4 of one suit, and then blah blah, and then one.
No, but baby steps. Let's not try to put all the things at once. Let's focus on one pair, four
No, I'm
sets.
just thinking, man, this impacts what we're doing, right?
Yaku is for open hands though, right?
No, both. Yaku
Both.
is the. It's just give me a moment, real quick. But finish what I was saying. I'm just saying.
Anyway, yeah, Yaku, Marinho, works over open or closed hands. Like, this table that Mageta is showing on the share right now, this is
Okay,
the
I'm back.
reason that I want to make a domain specific language because we're going to have to model all of these tables there.
I think it's a constraint, right, based. So you try to apply the first rule that matches in the or all possible rules that apply, I suppose. So like here, for example, let's go back here. So we're checking these, right? We're checking the Ricci case, the 7 pairs, and the Sumo. The difference basically is how you got the piece, right? That's
Yeah,
the
we're not
luck
even
base.
sharing that yet.
Yeah. Ipatsu is just a Ricci, but it's I think it's on the next turn. Let me see. Yeah, so it's on the next turn after you declare the reach, you beat the game. So you may make one Ipatsu. Anyway, whatever this, but there is these. So Pinfu, this is very complicated. So this is basically you have two possibilities of pieces to beat, and that gives you one point as well. So for example, uh, you are looking at one piece like two. You can have three. Actually, I don't think that's a good example, but like you have one piece in the middle and you can use both. You see, that's one case. But there's these, and now what the heck, right? It's this here. So if you have all triplets,
No, but that's very easy to check.
yes, but we need to parameterize the function to check the
No, no,
amount
no,
of
no. But
melds that we can make.
here's the thing, Mageta. We are checking these first conditions in particular, but in the future, when we develop the domain specific language, it's going to be a big OR, and we're going to have the declarations of each winning condition there in a big OR, and all of them will be valid for you to win. You see,
Yeah, I
Leisure?
think, man, and
Yeah, you
these have been
chose
a
one of
little
the most
hard.
complicated games to do
I and
properly.
I regret. No, I never did.
You chose like you either do it properly or you are fucked, essentially.
Man, there is also another rule which is Furitan. So it's like you need to see if the player has not discarded a piece that he's using on his hand, and that unqualifies his hand.
Man, we are so like this is so far away from like what a Monopoly game.
Oh yes, this is. Man, I think poker doesn't have these many
No,
rules,
poker
does it?
is way easier than this. Way easier. Poker is way
Man,
easier.
look at this. It keeps going.
Yeah, no, we are fucked. I already noticed that. Almost seems like you did in purpose. Here's what I'm gonna
I
do.
know a few, but man, what the heck? This I
Here's what I'm
have
gonna
no
do.
idea.
I'm gonna push all the play things that we had today, and then I'm gonna have to go. So add draft for Richie. Is that the one that you called?
Richie.
Ricci.
Richie.
Ricci.
Okay, so Marinho, if you want to continue doing because you're already typing the implementation of this particular winning condition, you can plug your solution to the melds.lfa, and then you can guys can go from there. I'm gonna stop the recording.
All right.